Physics Part 103. In the constant volume gas thermometer, the pressure of a fixed volume of gas measured by the height difference H is used as thermometric property. The differences between the scales of different gas thermometers become even less as the pressures used are reduced. This is because the lower pressure of a real gas, the more linear is the variation of pressure or volume. If we set up an empirical centigrade scale for real gas and constant volume thermometer by obtaining the pressure of the gas at ice point 0 degrees Celsius and the steam point 100 degrees Celsius, we can extrapolate the graph of pressure P against the centigrade temperatures to find the temperature at which the pressure of the gas would become 0. The extrapolated temperature will be found to be close to minus 273 degree on the empirical centigrade constant volume gas thermometer scale. If the experiment is repeated with the lower and lower pressures of gas in the thermometer, the extrapolated temperature tends to a value of minus 273.15 degrees. This temperature is known as absolute zero on the thermodynamic scale of temperature. It does not depend on the properties of any particular substance. We've got an example for you. The length of the mercury volume in mercury in glass thermometer is 25 millimeter at the ice point and 180 millimeter at the steam point. What is the temperature when the length of the column is 55 millimeter? Using the equation theta is equal to 100 P0 minus P1 divided by Ps minus P1. The thermometric property P is the length of the mercury column. Thus theta is equal to 100 into 55 minus 25 divided by 180 minus 25, which is equal to 19.4 degrees Celsius on the centigrade scale of this mercury in glass thermometer. Now it's your turn. Resistance thermometer has resistance 95.2 at the ice point and 138.6 at the steam point. What resistance would be obtained at a temperature of 19.4 degrees Celsius on the centigrade scale of this resistance thermometer? Thermodynamic temperature. As mentioned above, decreasing the pressure of a real gas makes it behave more and more like an ideal gas. For an ideal gas, the relation between pressure P, volume V, and temperature T is PV over T is equal to constant. Here T is the thermodynamic temperature. We now use the property of an ideal gas to define the thermodynamic scale of temperature.